Hello and welcome back. We're at section 3. This time we're going to take a short look at measures of dispersion. And you might first wonder, what is that? It just means how widespread the data are, really. Are they widespread apart? Or are they close together? That's what it means. So to do that, we're going to look at the range for the data set. So take a note of that. Range, an easy one. Standard deviation, not so easy, especially if you do it the way they suggest in these slides. Heaven forbid. Come on. Come to class, we'll go over a few things, and you'll be an expert in no time. All you really have to do is put the data into a list. Once you do that, you hit the Stat key, go to Calculate, and then choose one variable, Stats. The standard deviation will either be listed as small sigma or a small s, depending on where you get the data from. If the data is from the population, you've got all the data you'd really want, then this is it. If the data is from a sample, then S is your standard deviation. So S represents the standard deviation for a sample, which is actually an approximation for what we'd really like, because typically we want to know something about a population. And maybe we can't get information about all the population, so we pick a sample, a good representative sample, and get that standard deviation and say, well, that's probably pretty close to this if I did a good job of creating a sample. So let's start with the range. The range is really easy. Both these are measures of dispersion. This is so easy to do. Now, it's even easier than using with a calculator almost, although you would probably use a calculator for the range and find that out. And you'll see it's really easy. Standard deviation is better, more accurate, but the range can give you a real quick idea of the dispersion of your data, how widespread they are. See the spread? You can show the spread by using the range, or if you have some more time, standard deviation. Well, here it goes. The range is just the difference between the highest and lowest data values. So your highest data point minus the lowest data point, that's your range. Couldn't be simpler than that. The only thing you have to really do that is of any difficulty at all is finding out what the biggest number is in your data and what's the smallest number. Once you have that, subtract, you've got your range. And that's a simple method of showing the spread of your data items. Highest minus lowest, and you got it. For example, if Honolulu's hottest day is 89 and the coldest is 61, range is, go ahead, do it. Hit pause, do it, then come back. Did you do it? 89 minus 61, 28 degrees is the dispersion of that set of data from the hottest day to the coldest day. Next, computing the range. Here we've got some more. We've got the age of the 4 oldest US presidents. 70 is the high, 65 is the low. Just subtract those, and the range of those is 5. Now, to get the standard deviation, This will give you an appreciation for how much work your calculator is going to do for you. Find the deviations from the mean. This is what your calculator is doing. So you've got 5 data items, and I only see 4 here. This is rather strange. We'll see what happens. 70, 69, 68, 65, okay? I guess this should say 4 data items. Because we've got a 4 there and a 4 there. Basically, you just add them up, divide by how many you've got, and that gives you the mean. Remember, that's X bar. And for this set of data, it's 68. So that's your mean for those 4 data items. So these are the deviations. Deviation means how far is a 70 away from the mean? How far is it away from the 68? How far is 69 away from a 68? 68 is 0 from a 68, of course. And how far is 65 away from 68? Just subtract them. Take the data item first, subtract the mean, and you get your deviation. Next, we're trying to find standard deviation. We found the 4 deviations. The next thing you do is, after you get the mean, after you get the deviation, which is just subtracting the data by the mean, then you'll square all those deviations you got and add them together. Then divide by n minus 1. N represents the number of data items. In this case, there were 4. So we go 4 minus 1. We'll be dividing this sum of the squares by a 3. Take the square root of that result, and you've got your standard deviation. Now, with 4 data items, it's not too bad, especially if, in this case, all of them were integers. That's almost too easy, right? Well, there's an easier way of doing that, but here we've got the standard deviation, we've got the 68 for the mean, we've got all the deviations, and there are the deviations, 2, 1, 0, -3, and we square each one of those, and then we add all those squares up. Next, divide by n minus 1. In this case, n is 4, so we'll be dividing by 3. That gives us 4.67. Almost there. Take the square root. And now you've got the standard deviation. That's what your calculator is going to do for you. Now remember, if you don't have your calculator with you, bring someone else's. Of course, ask them first. Bring a good calculator with you, TI-83, TI-84, TI-Inspire, or something that someone shows you how to find these things if it's something that I'm not familiar with. There's our standard deviation, 2.16 for that data. And remember, I'll sneak back here as I can do it. So here was our data. Our standard deviation, or the typical distance that they're away from the mean, is about 2.16. That's sort of what the standard deviation means. A standard deviation. How far, if you picked one of these at random, you would expect it to be about 2.16 units away. And that, folks, is the range and the standard deviation. That's it. I'll see you next time, and we'll talk a little bit more about statistics. In the meantime, remember to bring your calculator. I'm going to take an inventory. Who has their calculator? All right. So before I take the roll call for the calculators, make sure you practice a couple of these maybe get an appreciation for what this calculator is doing for you. I know you don't want to do this by yourself. In the meantime, you take care, and we'll see you again.